Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Fatimah binti Muhammad Arif. In this video, I'm going to explain more about membrane separation. As what we know, membrane separation operates without heating. Therefore, it uses lesser energy when compared to conventional separation, such as distillation and sublimation. It's designed to demonstrate the technique of membrane separation. The design is also help the students and the researchers to carry out the membrane separation process. And actually, it widely used in the pharmaceutical industry. There are four types of membrane separation, which is reverse osmosis, ultrafiltration, nanofiltration, and microfiltration.
Microfiltration is based on the restricted diffusion of species through pores. Larger species or particles are restricted for entering pores of 0.1 to 1 micron in size. Microfiltration is a pressure driven with suspended particles and water as the retentate and dissolved solute plus water as the permeate. The use of hydraulic pressure accelerates the separation process by increasing the flow rate of the liquid stream but does not affect the chemical composition of the species in the retentate and product streams. The mechanism of microfiltration. The membrane functions like a body sieve. The fluid moves through a tortuous tube while the ions are discarded on the filter sheet. It can be clearly interpreted as a mechanical sieve with pores leading into a capillary creating a tortuous route. Mechanical trapping and adsorption may occur inside this tortuous tube. One of the applications is to remove the micron-sized particle such as bacteria.
Ultrafiltration is a membrane filtration process similar to reverse osmosis, using hydrostatic pressure to force water through a semi-permeable membrane. Plus, it is a variety of membrane filtration in which hydrostatic pressure forces a liquid against a semi-permeable membrane. Suspended solid and solute of high molecular weight are retained, while water and low molecular weight solute pass through the membrane. What does ultrafiltration remove? It removes endotoxin, plastic, protein, silica, seed, smoke and viruses. And it benefits? No need for chemical. Plus, it is a good and constant quality of treated water in terms of particle and microbial removal. Plus, it is also a simple automation and environmentally friendly. Next, we move on to the mechanism. Ultrafiltration system is a strategic way of water filtration through membranes. Membrane size varies starting from 0.1 to 0.001 micron. The systems are highly effective in removal of particles in higher molecular mass. This method efficiently screens out the bacteria and viruses. However, the compound element of low molecular mass such like sodium, calcium, magnesium, chloride and sulfate can be screened through the process. The ultrafiltration process primarily demands on low feed water pressure to attain the higher flux rate through the filtration membranes.
Nanofiltration is a relatively recent membrane filtration process that used most often with low total dissolved solid water, such as surface water and fresh groundwater. Purpose for softening and removal of disinfection by product precursors, for example, natural organic matter and synthetic organic matter. It has become more widely used in food processing applications such as dairy for simultaneous concentration and partial demineralization. Nanofiltration is a membrane filtration-based method that uses manometer-sized silicon through pores that pass through membrane at 90 degrees. It has pore size from 1 to 10 nanometer, which is smaller than that used in microfiltration and ultrafiltration. but just larger than reverse osmosis. The mechanism depends strongly on the membrane structure, on interaction between membrane and transported molecule. Efficiency of separation can be governed by sieving effect or by the solution and diffusion properties of solid molecule. For charged molecules, the electrical field has a determined role in the transport. There are three parameters that are crucial for operation of nanofiltration. First is solvent permeability, rejection of solute, yield or recovery.
My name is Wana Izzati Aina binti Wan Ahmad. I will explain about reverse osmosis. Reverse osmosis is a water purification process that uses a partially permeable membrane to remove ions, unwanted molecules, and larger particles from drinking water. In reverse osmosis, an applied pressure is used to overcome osmotic pressure, a colligative property that is driven by chemical potential differences of the solvent, a thermodynamic parameter. Reverse osmosis can remove many types of dissolved and suspended chemical species as well as biological ones from water and is used in both industrial processes and the production of potable water. The result is that the solute is retained on the pressurized side of the membrane and the pure solvent is allowed to pass to the other side. To be selective, this membrane should not allow large molecules of iron through the pores, but should allow the smaller component of the solution to pass freely. Reverse osmosis is most commonly known for its use in drinking water purification from seawater, removing the salt and other influent materials from the water molecules.
For the membrane separation application, first is in food industry, which is the drinking water production by reverse osmosis. The recovery of the organic vapors such as petrochemical vapors, recovery and the electrolysis of the chlorine production. Second is in the biotechnology, which is the water waste treatment. It is possible to remove the particles and the macromolecules by the help of the micro or ultrafiltration. And the last one is in pharmaceutical industry. As we know, about half of the market in the medical applications, such as use of artificial kidneys to remove the toxic substances by hemodialysis and artificial lung for bubble-free supply of oxygen in the blood.
Assalamualaikum and hi everyone, it's me Muhammad Muazzin and I'm going to address you the presentation on the membrane separation, specifically in terms of its conclusion and safety guideline. Alright, so first and foremost is the conclusion, and what we have here is the membrane separation generally is another type of separation process except for its low energy requirements. Also, it can be divided into 4 categories, which differs from others in terms of the pore size. So there are reverse osmosis or RO, nanofiltration, ultrafiltration, and microfiltration, MF. So in order for researchers and students to have a well understanding regarding this membrane separation thing, an equipment called membrane test unit TR14, which are well known and generally used to run the experiment. And last but not least, its application is widely used in our industry, for instance, food industry, biotechnology, and pharmaceutical. Now going to the safety guideline. Here you must know how to operate the equipment in order to avoid potential hazard that could harm you. Make sure you are fully aware about the experiment and always wear PPE. And also find suitable place to run this experiment and conduct the equipment. So I guess that's all from me, and I hope all of you will understand what I'm trying to deliver about the conclusion and safety guideline of the membrane separation. Thank you.